10th class exercise 2.1. The first question is, the graphs of y is equal to p of x are given in figure 2.10 below. For same polynomials p of x, find the number of zeros of p of x in each case. So this is the given figures. If you observe first one, how many zeros are existed to this polynomial? So if you observe, this polynomial does not touch the x-axis. That's why it doesn't have any zeros. So if you observe second one, it cuts the x-axis at one point. So it has 1 0. And now if you observe third one, here the polynomial cuts the x-axis at 3 different points, 1, 2 and 3. That's why it has 3 zeros. So if you observe fourth one, here this polynomial cuts the x-axis at 2 distinct points. So it has 2 zeros. Now fifth one, here this polynomial cuts the x-axis at 1, 2, 3, 4, 4 distinct points. That's why it has 4 zeros. It has 4 zeros. So here this polynomial cuts the x-axis 1, 2, 3. So it has 3 zeros. In this way, we can easily find out how many zeros exist by watching the graphs. This is exercise 2.2. Question number 1. Find the zeros of the following quadratic polynomials and verify the relationship between zeros and coefficient. First of all, to solve these questions, we have to check whether the given polynomials which are in the form of general form of the quadratic equations or not. So if you observe here, it is in the general form of the quadratic equation because here the x square term is there, here x term and then constant. So it is in the general form of the quadratic equation. So now we have to multiply the coefficient of x square and the constant term. Here the coefficient of x square is 1 and the constant term is -8. So it gives the -8 as the product. Now we have to split it into 4 2s are 8. So here, if you put the negative to the biggest term, then we can write x square minus 4x plus 2x minus 8. Here you can take x as a common, x minus 4. Here also you can take plus 2 as a common, x minus 4. Here x minus 4 is the common term. If you take common, x remains and plus 2 remains. So there are two chances. If x minus 4 is equal to 0, then x is equal to 4. If x plus 2 is equal to 0, then x is equal to minus 2. So 4 comma 0 are the 4 comma minus 2 are the zeros of given polynomial. Here, if you observe, if you add these polynomials, sum of zeros, that means 4 plus minus 2. It gives 4 minus 2 is equal to 2. It is nothing but minus b by a. Here, minus b means b means it is a coefficient of x term, and a means coefficient of x square, and product of zeros. So here product of zeros, 4 into minus 2, it gives minus 8. That is equal to c by a. Here c means a constant and a means x square coefficient. So this is the relation between zeros and the coefficients. Now, if you observe second one, you can split like this way. So this is the negative, that's why you can put negatives to the both 2's. So 4s squared minus 2s plus 1. So here if you take 2s as a common, here 2s remains, here minus 1 remains. If you take minus 1 common, here 2s and minus 1 remains. So here 2s minus 1 is the common term in both. So 2s minus 1 if you take common, here 2s minus 1 remains. So here if 2s minus 1 is equal to 0 one time and 2s minus 1 is equal to 0 second time. So s is equal to 1 by 2, here also s is equal to 1 by 2. So both the roots are same here. So sum of the roots, I am writing alpha plus beta instead of sum of roots. So alpha plus beta 1 by 2 plus 1 by 2. So 1 by 2 plus 1 by 2, half plus half gives 1. So minus b by a, here minus b is minus of minus 4 and c a is 4. So plus 4 by 4 gives 1 again here also. So alpha into beta, that means the product of the roots. Here 1 by 2 into 1 by 2 gives you 1 by 4. C by a, here c is 1 and a is 4, it gives 1 by 4. So in this way, similarly, you can find out this polynomial also. This is not in the general form of the quadratic equation. We have to convert. First of all, write the x square term and then x term and then constant. Here, if you multiply coefficient of x square into constant gives you minus 18. You have to split it. So I am splitting it as 9 2's. Here the x term is negative, that's why I am putting negative to the larger number. So 6x squared minus 9x plus 2x minus 3. Minus 9x plus 2x minus 7x. So here you can take the 3x as a common. Here 3x remains minus 3. So here, sorry, 2x minus 3. Here if you take plus 1 as a common, 2x minus 3. You can take 2x minus 3 common, here 3x remains and here 1 remains. So if 2x minus 3 is equal to 0, x is equal to 3 by 2. Here 3x plus 1 is equal to 0, x is equal to minus 1 by 3. So alpha plus beta is equal to 3 by 2 plus half minus 1 by 3. That means 3 by 2 minus 1 by 3. You can take LCM here. 3 2s are 6. 6 cancelled by 2 in 3 times. 3 3s are 9 minus 6 cancelled by 3 by 2 times. 2 into 1 2. It gives 7 by 6. So 7 by 6. That means minus b by a. Here also it satisfies the minus b by a. So alpha into beta. That means 3 by 2 into minus 1 by 3. So here 3 3 cancel, minus 1 by 2 remains. So minus 1 by 2. So c by a. So minus 3 by 6. It gives minus 1 by 2. So similarly, in this way, remaining problems also we can do it. Now fourth one, 4u square minus a cube. So here you can take 4u as the common. Here it remains u minus 2. So there are two cases. If 4u is equal to 0, then u is equal to 0. If u minus 2 is equal to 0, then u is equal to plus 2. So here alpha plus beta is equal to 0 plus 2, that is equal to 2. So that means minus b by a. Minus b by a. Okay. Minus 8 by 4. It gives you minus of minus plus 2 gives you. So alpha into beta is equal to 0 into 2, that is equal to 0. C by a. Here there is no constant term, so we can take c as the 0. So 0 by anything gives you 0. Now t square minus 15. So here only one possibility is there. T square is equal to minus 15. If it is equal to 0, then t is equal to root 15 plus or minus. So here alpha is equal to plus root 15, beta is equal to minus root 15. So alpha plus beta is equal to root 15 minus root 15. It gives you 0. So minus b by a. Here there is no t term. So that's why b it be taken as a 0. So 0 by anything is 0. It gives you 0. So alpha into beta is equal to root 15 into minus root 15. It gives you minus 15. So here c by a. Here c is a minus 15 and a is a t square coefficient 1. So minus 15 remains the answer. So now here it is a general form. So similarly in the exist manner. So 3 into 4 x square coefficient and constant of minus 4. It gives you minus 12. Now I am splitting into 4 into 3. So I am putting minus to the larger number. So 3x square minus 4x plus 3 minus 4. I am taking x as a common. So 3x minus 4. Here I am taking plus 1 as a common. 3x minus 4. Here 3x minus 4 is the common term. So I am taking it common. 3x minus 4 into x plus 1. Here first case is 3x minus 4 is equal to 0. The second case is 3x plus 1 is equal to 0. When x here x is equal to 4 by 3. Here x is equal to minus 1. Alpha plus beta is equal to 4 by 3 plus of minus 1. Gives you 4 by 3 minus 1. Here the denominator is 1. I am taking LCM. 3 ones are 3. So 3 cancel 3 by 1 time. 4 into 1 4 minus 3 cancel by 1 3 times. 3 into minus 3 minus 3. 1 into minus 3 3. So 4 minus 3 gives you 1 by 3 minus b by a. So here minus b. So minus 1 alpha minus. So plus by 3 and alpha into beta. Alpha into beta 4 by 3 into minus 1. It gives you minus 4 by 3 c by a. So here c is a minus 4 and a is a 3. So this is the relation between zeros and the coefficients of the polynomials. Exercise 2.2. Second question. Find the quadratic polynomial each with the given numbers as the sum and the product of the zeros respectively. Here given that alpha plus beta is equal to 1 by 4 and alpha into beta is equal to minus 1. So the general form of the quadratic equation when sum of the roots and product of the roots is given x square minus of alpha plus beta into x plus alpha into beta is equal to 0. So here x square minus alpha plus beta is 1 by 4 into x plus alpha into beta is equal to minus 1, that is equal to 0. So if you take LCM, 4x square minus x minus of plus minus by 4 is equal to 0. If you transfer it from there, so 4x square minus x minus 4 is equal to 0. This is the required quadratic equation. Similarly here also given that alpha plus beta is equal to root 2 and alpha into beta is equal to 1 by 3. So the general form of the quadratic equation when alpha and beta are given x square minus of alpha plus beta into x plus alpha into beta, that is equal to 0. So here x square minus alpha plus beta is root 2 into x plus 1 by 3 is equal to 0. If you take LCM, 3x square minus 3 root 2 into x plus 1 is equal to 0. So 3x square minus 3 root 2 into x plus 1 is equal to 0 here. So similarly here also given that alpha plus beta is equal to 0, alpha into beta is equal to root 5. So here the quadratic equation when sum of the roots and product of the roots is given x square minus of alpha plus beta into x plus alpha into beta is equal to 0. So x square minus alpha plus beta is here 0 into x plus alpha into beta is equal to root 5, that is equal to 0. So x square plus root 5 is equal to 0. In this way, now we are going to discuss about the fourth and fifth, sixth problems also. The fourth question is here given that alpha plus beta is equal to 1 and alpha into beta is equal to 1. Here the quadratic equation when the sum of the roots and product of the roots are given x square minus of alpha plus beta into x plus alpha into beta is equal to 0. So x square minus here alpha plus beta is 1 into x plus alpha into beta is here 1 is equal to 0. X square minus x plus 1 is equal to 0. This is the required equation here. Now here alpha plus beta is equal to minus 1 by 4 and alpha into beta is equal to 1 by 4. So the general form of the quadratic equation when sum of the roots and product of the roots are given x square minus of alpha plus beta into x plus alpha into beta is equal to 0. So here x square minus of alpha plus beta is here minus 1 by 4 into x plus alpha into beta 1 by 4. If you take LCM 4x square minus of minus plus 1x plus 1 is equal to 0. If you transfer 4 to that side, right hand side, 4x square plus x plus 1 is equal to 0. This is the required quadratic equation. Next, last one, here alpha plus beta is equal to 4 and alpha into beta is equal to 1. The general form of the quadratic equation when product of the roots and sum of the roots are given x square minus of alpha plus beta into x plus alpha into beta is equal to 0. So here x square minus alpha plus beta is 4 into x plus alpha into beta is 1, that is equal to 0. So x square minus 4x plus 1 is equal to 0. In this way we can find out any quadratic equation when sum of the roots and product of the roots are given. For example, if they given zeros of the polynomial, that means alpha and beta, then also we can easily find out sum of the roots and product of the roots, and then we can find quadratic equations. That's it.